Today we'll be looking at section 6.1. So we're talking about expressions and how to deal with that. And this is pretty much what people think of when they think of math. And I'm going to remind you that you've heard a lot of statements out there of PEMDAS probably. Maybe on Facebook, they might put something on there like this, evaluate this expression, and so on. And there are arguments back and forth about what that expression really evaluates to. And then somebody will invariably say, don't forget PEMDAS, that answers it. But let's talk a little bit about what PEMDAS is first. So PEMDAS is an agreement that we have made as to the order of operations, the order in which we will solve or simplify an equation or an expression. So we'll simplify expressions and we'll solve equations. And so PEMDAS is just an acronym, and it stands for mathematical expressions or mathematical functions that we will apply. And those will help us make sure we get everything in order. So we'll start with P, which are parentheses. And then we'll go to exponents. And then we'll go to multiplication and division. And last but not least, we will do addition and subtraction. So these functions done in this order will make it so that everybody gets the same result, and those arguments on Facebook become pointless. Notice I said multiplication and division together, and I said addition and subtraction together, and that's because those are of equal value. So if all you have is addition and subtraction, you can just work that left to right. Or if all you have is multiplication and division, you can work that left to right. But regardless, we would start with parentheses. Anything you can do on the innermost set of parentheses, you want to do that. And then we'll work to exponents and work out from there. So let's go ahead and take a look at this function that I mentioned earlier. And it says we need to evaluate this function for x equals 6. Now it's got an x in there, and I know that bothers some people, but the reality is it's just a placeholder. It's a spot that says I know a number goes there, but I don't know what it is. And we commonly use X, Y, or Z, but really you could use whatever you want. You could use a smiley face, or you could use Greek letters, just something to highlight that that's a placeholder. X is common, but it's not magical or anything. And what we're saying here is that we want X to equal 6. So that's what we will put into our placeholder. So I'll rewrite this as 7 plus 5 times the quantity, and I'll go ahead and write that 6 in red so that it differentiates it a little bit. It doesn't really matter. It's not magic that it's red. I just want to highlight that that's where X was, and I replaced it with 6. Okay, so now we'll start with our parentheses. Parentheses say I need to work what's inside the parentheses first. And so the first thing I will do is subtract 4 from 6. 6 minus 4 is 2. Now notice I left the parentheses here, but that's because whenever we have a number written right in front of the parentheses, like this 5 is, right in front of the parentheses, then that means multiplication. And I left the parentheses around the 2 so that I could remember that I needed to multiply that. But regardless, my next step is over here, exponents. We've done our parentheses, now we need exponents. So my next step is to do just this part, 2 to the 3rd power. And recall that an exponent of 3 means you take whatever the base is, in this case 2, and we need 3 of those, so we could write that 3 times, and then you multiply those. 2 times 2 times 2 is 8. So I now have 7 plus 5 times 8. So I've got my exponents done. Now I need to do multiplication or division. And we have a little multiplication problem here, so I'll do that one. 7 plus 5 times 8 is 40. And now the only thing I have left is addition, so I'll do that. And this would evaluate as 47. So that would be the evaluation of this expression when x equals 6. We just follow that order of operations. Maybe we'll have another one here. And so I've got now a new expression, x squared plus 5x minus 3, and I'm evaluating that for x equals negative 6. So I will rewrite this, and I'm going to put parentheses everywhere there was an x, and I'll fill those x's with a negative 6. So a negative 6 in here and a negative 6 in there. Now, I've got negative 6 squared, and recall that the exponent says I take that many of that base number, so there are 2 of those, and I multiply those together. A negative times a negative is a positive, and 6 times 6 is 36. So negative 6 quantity squared is 36. Now, I do want to note here that negative 6 squared does not equal negative 6 quantity squared, because due to our PEMDAS idea, I would need to do this exponent before I apply the negative out in front. So what we're talking about here is squaring 6 is 36, and then I apply the negative. Whereas up above, we just proved that negative 6 times negative 6 is a positive 36. So you can see those are not equal. So be really careful when you are raising a negative to a power. You may, in your calculator, have to put the parentheses in there to make it do what you want, so that you're squaring the negative and not negating the square. And so just watch for that. Check how your calculator does it. Maybe type in negative 6 squared and see if that gives you positive 36 or negative 36. If it gives you a negative, then you better add parentheses every time you square a negative. So watch for that. Okay, now we'll keep evaluating this. Negative 6 squared, we just said, was 36. 5 times negative 6, we're adding this, 5 times negative 6 is negative 30. Then we still have the minus 3. Now I've got this plus a negative right there in the middle, and it turns out that when you add a negative, that is exactly the same thing as subtracting. And so I'll go ahead and rewrite that plus a negative as minus. And so we've done our parentheses. There weren't any, so we didn't worry about that. We did exponents, where we squared the negative 6. We took care of the multiplication, the 5 times negative 6. There was no division. All we have is subtraction. 36 minus 30 is 6. And then we have minus 3, which is 3. So that would be the evaluation of this particular expression when x equals negative 6. Now let's look at another one. We'll just keep working our way through. We have a new expression. Now this one has 2 variables, notice. It's got an x and a y. And so we'll have to account for both of those. And as it turns out, they tell us that x is 4. So everywhere there's an x, I'm going to replace that with a 4. And they tell us that y is negative 2. So everywhere there's a y, I'm going to replace that with a negative 2. I'm going to go ahead and rewrite this with parentheses where my variables go. And then I'll just fill those in with their values. This kind of helps me ensure that I get the right variables in the right spot. So x is 4. This was an x, and this was an x. And y is negative 2, so I'll put a negative 2 here and a negative 2 there. All right, so there is nothing I can do inside parentheses, but we can do exponents. 4 squared is 4 times 4. That's 16. And I also have a 3 negative 2's that I need to multiply together. A negative times a negative is a positive, and then that positive times one more negative is a negative. And 2 times 2 times 2 is 8. So this will be negative 8. So now I can plug those in. We still have our negative 2 out in front. 4 squared, we said, was 16. And then I'll go ahead and leave these here for right now. When we do our multiplication, we'll take care of those. And then minus negative 2 cubed, we said, was a negative 8. So once again, I've got this minus a negative thing, like I had a plus a negative before. Minus a negative becomes a plus. So maybe sometimes I'll just overwrite that with a big plus. Now I'll go ahead and do my multiplication. Negative 2 times 16 is a negative 32. We'll do the plus. 5 times 4 is 20. Times negative 2 is negative 40. And then we've got plus 8. Again, we've got this plus a negative, which is minus. So negative 32 minus 40 plus 8. And we've taken care of that. Now we're down to addition and subtraction. So we can start with the first two. Negative 32 minus 40 is negative 72. Add 8 to that will give me a negative 64. That's the evaluation of this expression. So we can have multiple variables in there. That's fine. We'll just replace the appropriate variable with the value they gave us, and we will have our evaluation then. All right, now let's take a look at perhaps a time we might use that evaluation idea. Here on the right-hand side, we have a graph that shows the calories needed to maintain energy balance for a moderately active lifestyle. And it looks like based on the legend here, the red is talking about women and the yellow is talking about men. And then over here on the left-hand side, they give us a mathematical model. What they're trying to do with that equation is model the shape of the curve that connects the top of the bars. So some curve that peaks in the middle might be modeled with this particular equation. And they tell us that the calories needed per day is the W. And they tell us that the age group is the X. Notice we've got age ranges down here on the bottom of the graph, but then up above they give us age groups. So we need, according to the text, the group number for X. So now let's look at the question. How many calories per day are needed by women between the ages of 19 and 30? Well, that's this age range right here. But recall, what we really need is the group number. So I'm going to take this group 4, and I will replace X with 4 in the mathematical model. So the mathematical model is W equals negative 66 times 4 squared plus 526 times 4 plus 1030. And now I am evaluating the expression on the right, the full equation, when X equals 4. And so we've got our negative 66 times 4 times 4 is 16, plus 526 times 4, still kind of using PEMDAS here, plus 1030. So 66 times negative 66 times 16. I'm going to grab my calculator here, make sure I don't mislead you. So negative 66 times 16 is negative 1056. 526 times 4 is 2104. And then we'll add 1030 to that. And now we're down to the addition subtraction. So we've got negative 1056 plus 2104 plus 1030. And that gives me 2078. So that's suggesting that a woman between the ages of 19 and 30 would need to eat 2,078 calories per day. And now they ask us at the end, does this underestimate or overestimate the number on the graph? So we come back to the graph, the yellow are the women, remember? And it says on the graph, they need 2,100. And I'm a little below that with this model. It's really close. It's only a difference of 22 calories, but it is slightly different. So underestimate is what our model did, because the graph itself is made from real numbers. The model is trying to model that graph, trying to make an equation that matches it, and it's just a little under for this age range. Super close, but just a little under. So that's a way we can use this evaluation tool within a little bit of science. All right, let's look at some ideas here. Now, what we need to do is define some terms. So anything separated by an addition is a term. And I know I said addition and this is subtraction, and we already showed that adding a negative is subtraction, so it's kind of like adding a negative. So 7x is a term. And in that term, we have the 7 and we have the x. The x is the variable, meaning it can take any number. And 7, because it's multiplied and written in front of, that's our coefficient. So when you hear the term coefficient, we're talking about the number in front of the variable, which is multiplied by that variable. And as it turns out, we also have this idea of like terms. And like terms are terms with the exact same variable with the exact same exponent. So 9x and 7x are like terms. 9x and 7x squared are not like terms because the x is squared. That makes the difference. Now, we can add like terms. So we can add like terms. And the way we do that is we just add their coefficients. So if we had 9x plus 5x minus 3x squared minus 2x, it turns out that we have 3 like terms, which we can add together. And so we would have 9 plus 5 minus 2 all times x, and then we have just that minus 3x squared. 9 plus 5 is 14, minus 2 is 12, so we would end up with 12x minus 3x squared. And there's nothing else we can do to that because we have unlike terms. If they were alike, we could continue to add, but since they are not like terms, we cannot. And so that's just a definition there so that we're prepared for anything that'll come down the pike there. All right, so let's look at some properties. We have certain properties that we will use when simplifying or evaluating expressions or solving equations. We've got the commutative property. We've got the associative property. And we've got the distributive property. And as it turns out, the commutative property works for addition and multiplication. The associative property works for addition and multiplication. And the distributive property is a multiplication. Let's see what we're talking about. With commutative property, thinking about a commute, you're talking about your trip from home to work or vice versa. So it's kind of how it moves from one thing to the other. And that's what we see with the commutative property. As it turns out, 3 plus 2 is 5. And that's the exact same thing as 2 plus 3. Notice you can write them in different orders, and that works just fine. Same thing with 3 times 2. That means exactly the same thing as 2 times 3. So we don't have to do it necessarily left to right, but we could do right to left and get the same result if all we have is this multiplication, if there's no addition in there. The associative property is really what are we looking at? So if I had 3 plus 2 plus 5, and I did the 3 plus 2 first, that would be the exact same thing as 3 plus 2 plus 5, but doing the 2 and 5 first. If we do the 3 plus 2 first, that's 5, and 5 plus 5 is 10. If I do the 2 plus 5 first, that's 7, and 7 plus 3 is 10. So it doesn't matter which ones we do first. Same thing if we're multiplying. 3 times 2 times 5 is the same thing as 3 times 2 times 5. But let's say we do the 3 times 2 first, which is 6, times 5. Well, that's 30. What if we do the 2 times 5 first? Now we have 3 times 2 times 5 is 10. 3 times 10 is 30. So you can see it doesn't matter what order we do those. All we had was multiplication, and so you could do them pretty much in any order. Now the distributive property, I like to think of it as kind of like dealing cards, where you give one card to each player and then come around and keep doing that. And so it's kind of like maybe we have this 3 out in front, and I've got an x plus 5 inside parentheses. Well, then maybe I'm going to distribute this 3 as if I were dealing cards to everybody sitting at the table, or everything inside the parentheses. And so I'll end up with 3 times x, which we write as 3x, and 3 times 5, which is 15. So I've distributed that number out in front to everything inside. Now that only works when there is no symbol written between the number and the parentheses. If we did have a symbol, like 3 minus x plus 5, now I'm not going to distribute that 3 because that 3 isn't multiplied by x plus 5. X plus 5 is actually subtracted from the 3. But one little trick I can do when there is no number there is pretend there's a 1 and distribute that 1 through. And now I still have my 3 out in front, but this negative 1 times x is negative x, and negative 1 times 5 is negative 5. Now I do have some like terms here, 3 minus 5, which I could rewrite now as still have that negative in front of the x, and 3 minus 5 is negative 2. So if you do have a symbol like that minus sign, we could put a 1 in front and distribute that through. And notice I got rid of the parentheses at that point. That is an option. If you have a number with no symbol, though, then you distribute the number to everything within the parentheses. And that works pretty well. So let's go ahead and simplify an expression here, and we'll use that idea. I can see we've got some distribution going on, because I've got 6 times a set of parentheses, and then I have 10 times a set of parentheses. So I do the distributive property twice. 6 times 2 is 12, and we have the x squared. 6 times 4 is 24, and that just has an x. And now 10 times 4 is 40, and we still have the x squared. 10 times 3 is 30, and we just have an x. However, now we have sets of like terms. So those both have an x with no exponent, and both of these have an x but with a squared term. So again, I'll just add my coefficients. 12 plus 40 is 52, and those are my x squareds. 24 plus 30 is 54, and those are my x terms. So now I have simplified by distributing the 6 and the 10, and then combining like terms. And that seems to work pretty well. Let's look at another one. So here we've got several things going on. we've got this negative out in front of a set of parentheses. So maybe I could put a 1 and distribute that. Another thing I can do, if you don't like the 1 idea, is we can distribute the negative through and drop the parentheses. So this could be 5 and change the x to a negative x and change the -3 to a +3. So it could be done that way. That works just the same as distributing the -1 through. Either one will work, but we'll need to somehow get that through. Notice I'm not distributing the 5, just the negative, but then I will have to distribute the 2 through. That'll have to be sent through, but let's get to that. That'll be a little bit later. So I've got this 8x plus 2. Now I've also got this bracket thing. As it turns out, that bracket really is just a set of parentheses. We may start with the parentheses we're used to, but if we have a set of parentheses outside of that, we change those to brackets, just so that it's easy to see that that's the same set of parentheses. And if you have another set outside of that, we usually change it to braces. They all mean parentheses. It's just a different way to write it, so it's very clear where that set of parentheses starts and ends. Okay, so I'm going to distribute that negative through, -x plus 3. And I'm going to keep those as brackets just because that's what they were first. Let's go ahead and combine some like terms. I see 5 and 3 are like terms. So I've got 8x plus 2. Now I'll go ahead and switch it back to parentheses. We have a -x plus 8. And now I can distribute the 2 through within that set of parentheses, and it drops the parentheses. 2 times -x is -2x. 2 times 8 is 16. I have a set of like terms that I can add. 8 minus 2 is 6, and those are x's, and I still have the 16. So now we've simplified this expression using those properties. We had a distributive property a couple of times. We added like terms a couple of times, and we got a good simplified expression. Okay, so those are some good examples, I think, of what we're talking about here in 6.1. Again, we looked at expressions only, no equations, but we evaluated them by plugging numbers in. We looked at ways to combine them and simplify an expression. We just played a lot with expressions, and in 6.2, we will make equations by setting 2 expressions equal to each other so that we can solve them. If you've got questions, let me know. Otherwise, hope you find this useful.